We are going to be hearing from Dr. Jose Almirall. And Jose is a professor of chemistry at Florida International University, where he also leads the Forensic Research Institute. In his previous life, he was a trace evidence examiner at the Miami-Dade Police Department. He's also the former chair of the SWIGMAT Glass Group, and he keeps an interest in improving the practice of trace evidence analysis. And he will be giving us an update on the Elemental Analysis Working Group.
I'm going to talk about the Elemental Analysis Working Group. It's a group that was funded by the NIJ and organized by Florida International University. And I want to give credit to Tatiana Trejos and Robert Coons, who both of whom are here, but also to the rest of the EAWG members, and I'll mention them later, for their contributions to this work that I'm going to describe. So if you're here, you're probably a glass examiner or have an interest in glass examinations. And I don't have to tell you how important and relevant it is to conduct elemental analysis. As early as 1986, David Hickman published a paper describing the chemical analysis of glass by ICP-AES. And since then, there have been other notable papers. I'm just mentioning a few here: Bob Coons, Wilfred Stocklein, and Stefan Becker, some by our own group. And then an effort that was funded by the European Union called NICRIME that I'll discuss later, which eventually led to a standardization or attempt to standardization of laser ablation ICP-MS, which was a big move forward in elemental analysis of glass. So I'm going to talk about what is the EAWG, if you don't know by now. Why was it formed? What was the motivation? Why is it important to standardize? I think yesterday's comments by the panels in the afternoon mentioned this. Why is it important to standardize the analytical methodology when we can do it? We can't always do it, but when we're able to do it, as in the case of elemental analysis, we should strive to do that, including the analysis of the data. How do we treat the data? We should all be doing the same thing if there's an opportunity to do so. I'm going to talk about how we designed some interlaboratory trials. We call them round robins. Round robins strictly are the same sample passed around to different labs sequentially, but we are taking samples from some sets and giving them out to the laboratories to conduct the analysis. And there is a fragmentation in our glass analysis community. Some people are doing XRF, some people are doing ICP-MS solutions, some people are doing laser ablation ICP-MS, and there is now an interest in laser-induced breakdown spectroscopy, so I'll talk a little bit about that. So how do the methods perform, and then how do the match criteria that we apply to the data that are generated perform in terms of the type 1 and type 2 errors? And we just had a presentation discussing type 1 and type 2 errors. We also aim to come up with what can we say? What does it mean when we do find a match? It's easy when we can tell them apart, and everybody can do that, write a report. But what do we write in the report, and what do we testify in court when we do find the match? That's a little more difficult to do, especially even with these high discrimination examinations. And then another thing that came up yesterday was, okay, well, what about disseminating this information to the operational laboratories? How do we train the people to do it, and how do we get them to apply the research that's been conducted? That came up specifically yesterday, and those are the aims of the EAWG. So the NICRIME group was this European funded effort that lasted 5 years, approximately 5 years, from 2001 to 2005. And Stefan Becker actually was the person who was in charge of the glass task of the NICRIME effort. It was broader than just glass analysis, but it dealt with isotope ratio and elemental analysis. And we, my group and the FBI laboratory and Vincent Zadanowicz from Customs, I think those were the only people who were from the United States that participated in this effort. We learned a lot from this effort. And we know that laser ablation ICP-MS, we can call it the gold standard for doing elemental analysis of glass. And that is so because the limits of detection are very low in comparison to the expected typical concentration range in the glass. So many, many years ago, we began to identify what are those elements that we want to look at that are going to be discriminating, and then how do we make use of this instrumentation. There are hundreds of citations in the analytical literature on the use of laser ablation ICP-MS for other things, and glass just happens to be a very homogeneous matrix that lends itself very well to do this. And the other thing about laser ablation ICP-MS and this elemental analysis in general is that it works when we do multivariate analysis because we can combine the discrimination power of the different elements. So you can see the concentration of strontium on the y-axis, and you can see the error bars for the measurement. And most likely, those error bars are related to the variation of strontium in the glass itself, because the measurement error is even smaller than that. But we can see we can discriminate many of these samples. All of these are glass samples. I got these, I think, from Scott, that have the same refractive index. We can't discriminate them by refractive index, but we can discriminate many of them by just strontium. When we add a number of other elements that are not related or not correlated, we get excellent discrimination. So when we have glass from different sources, we can discriminate between them. Now, we have this fragmentation in the community. Some people are using SEM-EDS. That has what I would consider poor discrimination power because of the limit of detections and other factors. But XRF, laser ablation ICP-MS, and now LIBS are being widely used. So I asked the question, well, how do these methods perform? We know laser ablation ICP-MS works well. There are a number of labs, maybe up to 40, that are using XRF. And there are people who are wanting to use LIBS. Well, why don't we examine these to see what is the real performance? So that was one motivation behind some research that we proposed to NIJ in 2005. And we came up with, a lot of the research dealt with looking at LIBS as a possibility. So we have some of my students who are now, well, some of them escaped already. Ben Naez and Cleon Barnett are at different places, but we still have some students. Erica Cahoon, you might have seen her poster today on LIBS for glass analysis. But I want to bring your attention to this particular paper, which directly compared laser ablation ICP-MS with XRF and LIBS. And in that paper, we conclude that the performance of these methods is equal. Now, I collaborated with a very able XRF person, Scott Ryland, on this paper, and I said, well, maybe it's just Scott. You know, he's so good. And so we proposed to NIJ to involve other people, other labs, because there was a fragmentation even within the XRF community. Everybody was doing something different. And if you look at the proficiency test results, in 2007, CTS put out a test in which there was no difference for all of the combinations of comparisons that you were required to do. And in that year, 27% of the respondents either reported inconclusive results or incorrect results. Now, that's a typical case scenario when the evidence comes to you. Usually, it's because, you know, they might match. So this was a match for all the combinations. 27% of the people said inconclusive, or they incorrectly said they were different. This is a problem. So this motivated us to write a proposal to NIJ to bring people together, create a mechanism for practitioners to share their knowledge and experience And we purposely selected some people who were just starting out in XRF analysis and laser ablation ICP-MS analysis into the group, as well as some experienced people. And so I list the agencies. Right now we have up to 23. We have state and local labs, federal labs, private labs, international labs, and we were limited by the number of people we could invite by the funding that we got from NIJ. And you can see the people who were actually funded by NIJ have the asterisks, mainly state and local labs. So that was the impetus of creating the working group. The aims were to improve the forensic analysis of glass through validation, standardization for the different methods. We already have a standard method for solution ICP-MS analysis that was developed through efforts in my group. And so we wanted to develop standard methods that we can submit to ASTM for XRF and laser ablation ICP-MS, and possibly for LIBS for glass, and then maybe look at other matrices. So we designed some interlaboratory tests that were designed to inform the participants on the performance of the methods they utilize through feedback and provide some insight on the match criteria selection and significance of a match when a match was found. And then we wanted to bring in an even wider community, the community of SWGMAT, experienced trace examiners, so that, and this is a lofty goal, so that we could develop some sort of a common language that we can use to communicate the findings of elemental analysis comparisons of glass evidence. This proposal was written in 2008. And we have had many meetings. We've had tests that went out to the participants. They spent a lot of time analyzing the test, returning with results. We gathered. We find it very important to get together and spend 3 days discussing the results. I think that a lot of people got a lot out of that and eventually improved their methodology and optimized the methodology, eventually converging into some minimum requirements for doing these methods. Now, not everybody has the same instrumentation, but at least we set some minimum requirements towards standardization. So we met these times, and then we met again in May of this year in Chicago to discuss writing the standard methods. So I'm not going to go over the results of the round robins so much because there's a talk tomorrow because Tatiana Trejos is going to discuss match criteria performance. So I'm not going to steal her thunder, but I just want to give you an idea of the round robins that were submitted. We submitted standards, reference standards, NIST standards, as well as comparison samples. We recommended an element menu that people should use, the number of measurements, and so forth. There was already a very good night crime method that was developed for laser ablation ICP-MS, so we started with that. And when we got the results, we got very good agreement for round robin 1. And then we designed the second round robin. We sent some more standards. We learned a little bit from the first round robin. And then we asked everybody, what we learned from the first round robin was that we should ask everybody to normalize the data to a reference standard 1831, the XRF people, and that improved the results tremendously. We still had comparison samples. We asked people to compare samples. 2 of them were the same, 2 were different pairs, and we got very good results, except for 1 ICP-MS lab. We have 100% association and discrimination for the most part, but the match criteria that was used was all over the place. Now, it didn't matter because in this particular case, it just, the type of glass that it was, everybody got the same associations, and everybody got the same discrimination because they were very different, and they were also very homogeneous. So it didn't matter what match criteria you use in this particular round robin. So we try to make it a little bit more difficult. And in this case, we specifically designed the examinations or the trials so that we could evaluate both type 1 and type 2 errors. So we had a third round robin where we had samples manufactured at the same plant at different time intervals ranging from 2 weeks apart to 2 years apart. Some of the samples were selected to have very, very close elemental composition. We have a database in our group, so we could look up to see which ones are very, very close. And we focused on round robin 3 towards the evaluation of false inclusions, since these samples were selected to be challenging due to very close elemental composition, although they were made at different times. And in the fourth round robin, we did the opposite. We were looking for samples, we knew they came from the same source, and they were made at the same plant, and very close together. So I'm just going to tell you the types of labs that participated: XRF, 7 XRF, 2 LIBS, 9 ICP-MS, and we got most of the responses back by the due dates. And these are all float glass samples. And in round robin 3, we also did a container glass set, which we're not going to talk about too much, but we've already published that there's a lot of inherent heterogeneity in container glass that is greater than in float glass. So you have to be aware of that when you're doing your sampling. So there's more heterogeneity, so your sampling scheme has to be better, or take that into account. So I'm not going to go over the results, just to tell you that ICP-MS, we had a lot of different element menus being used by the different laboratories. Different instrumentation were involved, different manufacturers of instruments, as well as in the XRF users, as well as the LIBS users. And you can see that we don't prescribe specific XRF parameters. We say you should use a minimum of, this excitation voltage, for example, a minimum of acquisition time. So that helps to improve the results. So I'm not going to go over the results. Tomorrow you'll have to come to Tatiana's talk, but I'll leave you with some conclusions from what we learned over the 4 round robins. First of all, for the XRF users, the use of normalized data to normalize to 1831 has provided a way to account for differences between instrumental configurations and to conduct inter-laboratory comparisons, or even intra-laboratory comparisons over different days. The use of a glass standard as a control is recommended also to check for method performance prior to analysis. The analysis of K and Q fragments with similar size and shape is necessary for satisfactory results, and we've also recommended a minimum number of measurements for the Ks, where you should have enough sample to do that. Then we started to make recommendations about the minimum limits of detection, and you heard Troy's talk, as well as the recommended match criteria for XRF. And you heard Christine's talk, where we say spectral overlay, where a lot of people do, and then plus or minus 3 standard deviations of the means, or range overlap. These are fairly easy to do, and they perform well in terms of false exclusions and false inclusions based on the typical sensitivity and precision that we have seen for this method. So we see very good consistency across all the laboratories right now. And in addition, the very difficult, I thought, trials that we had designed, we found that XRF methods were able to detect significant differences between fragments of glass that were manufactured in the same plant in short periods of time. That period of time is dependent on the variability of the formulation of the glass within the plant. For instance, XRF participants were able to detect differences in samples manufactured at this Cardinal plant that we have samples for 1 month apart, but not 2 weeks apart. However, we went to another plant and got samples of Pilkington plant in another location in another state, and there the XRF participants were able to distinguish the glass manufactured 2 weeks apart. For ICP methods, we found that when standard methods of analysis are used, Excellent consistency between the participants has been achieved for comparison of glass, and a large variety of match criteria are still being used. So we came up with a recommendation because the precision is very, very low for the ICP-MS experiment. So what we're saying now is that we should use a wide match criteria, plus or minus 4 standard deviations of the means, and maybe even a minimum RSD precision value when we're doing that comparison. So finally, ICP-MS methods were able to detect significant differences between fragments of glass that were manufactured in the same plant in very short time periods. So the products of this EAWG will be 2 publications describing the result of the round robins. We expect to have 2 standard methods submitted to ASTM very soon. And there have been many presentations at this symposium. Tomorrow, Tatiana Trejos, we've had several posters today, and then you've heard the 2 talks by Troy and Christine emerge directly from work from this group. So what's the current and the current status and the future? Well, we're looking at other matrices, bulk analysis of soil. So we conducted a first interlaboratory trial, and there was a poster by my student Sarah on that today. We also have shown that LIBS is a viable alternative to laser ablation ICP-MS and XRF for glass analysis. We had 3 labs participate in the last round robin for LIBS, and we don't talk about the LIBS data so much until we get more participants in. I think we need a larger number of laboratories. We do plan to publish match criteria results for these round robins, and we are going to seek input from the glass examiners of SWIGMAT before we submit these methods to ASTM for consideration. So what about significance? What do we say in the report and in testimony? Well, that will vary depending on the conditions of a particular case, as was mentioned yesterday. What are the particular conditions that are relevant? The instrumental methods that are used, the number of fragments that are found that match, the number of different sources that are found that match, the location of the recovered fragments. Was it found on a shoe? Was it found on the head, hair? How common or uncommon is the glass? And then there's this other domain-relevant context that we talked about yesterday. So I want to thank the people in my group who do all this work, the students, Tatiana and Bob Coons for doing data analysis, James Karan for contributing Hotelling's TR script, which we didn't talk about, but it's something we're looking at very carefully. That's the multivariate version of the t-test. Seems to perform very well when we're doing these multivariate comparisons. And then all of the EAWG participants. I just want to end with a note or announcement that we have been funded by NIJ to offer training workshops, 1-week workshops, and they are free to people who apply, and some of you have already participated. And in December 5th through the 9th, I think it is, we are offering elemental analysis of forensic evidence with a focus on interpretation. And that's where we will be describing and relaying some of the lessons that we learned from the EAWG. If anybody's interested, you can go to the website, download an application, and send it to us. If anybody's interested in samples from round robin, even if they're already done, if you want to do them after the fact, please contact me. Thank you.
Thank you, Jose. At this time, we'll take questions from anybody in the audience, and I've been asked to let you know that the microphones are having a hard time picking you up since you're out there. So if you have a question that you need to ask, please speak very loudly. So do we have any questions? Yes, Bart.
Question for Troy. I missed the page numbers for the analytical chemistry.
From which article?
Your analytical chemistry 1981, 1982.
I can get those to you. I don't have it right here, but
Any other questions? Yes, ma'am.
I'm not a statistician, and I don't know anything about Bayesian work either, so please forgive the ignorance of my question, but did I hear you correctly, Mr. Commander, that you're assuming that all the fragments from the recovered glass come from a single source, and you're factoring that in deciding that you should analyze multiple particles of that recovered sample? Did I hear you correctly?
So the first assumption was that all the samples I had came from the same type. So that way we can assume the normality across all the different means. I was saying that for the fragments themselves, I was assuming that you had multiple fragments from, like the fragments that you pulled off the suspect and the fragments from the control were both, like each of those sets individually, you assume are uniform for whichever they came from. So if you found them at the control, you assume they all came from the same object, or and on the suspect, they all came from the same source as well.
Okay, so I guess my question is, in case where we can't make that assumption, for example, if I receive a car mat and I'm screening it for glass, obviously I can't assume all the glass on that floor mat came from a single source. So is that assumption inherent in the Bayesian hypothesis, or is it just something you were doing for your work?
Well, so based on the literature I was reading, they had assumed that they had multiple that they could assume came from the same source. After listening to more presentations from actual forensic scientists, it appears that you're right, that typically when you find fragments off of objects or off of people, you can't assume that they came from the same. So in that case, you would change the sample size when you're doing the power in the calculations to be just a single one. And at that point, it's going to be limited by the uncertainty in the covariance structure that you estimate, because you don't have the sufficient sample size to depend on at that point.
Any other questions? Well, I thank everybody for attending the session today on glass, and that will be it for us today. And thank you to our speakers.